All right, so here is next section, 3.3. We're talking real zeros of polynomials. Real means that there's no imaginaries in this section. The next section that we talk about, we will get into some imaginary zeros and finding those as well. So this one's all the real numbers. When we say real, though, they don't have to be nice. They could be square roots. But what we won't see in this part here is any i's, so any imaginary. And when we say the real zeros, we are finding all of the real locations where it crosses the x-axis. So essentially, we're finding all of the x-intercepts. So this section might take a little bit longer. Each of the questions just is a little bit more, it just takes a little bit longer to kind of work through. So let's go ahead and get started. All right. The rational zeros theorem is quite intense. There's a lot going on here. But what it says, and I'll just point out the most important parts, is if you have a polynomial, then I don't really like how that's written. Okay, so if you have a polynomial, then the possible rational zeros, would happen at factors of the constant term over factors of the leading coefficient. And these are possible places where it will cross the x-axis. All right, so possible locations. It doesn't tell us the actual, it just says, hey, here's a list of possible places where it will cross. What we'll do is we'll take the list of possible ones and we'll find where it actually crosses at. All right, so it says use the rational zeros theorem to list all the possible, emphasis on the word possible, zeros of the function. So it does not want us to list all of the zeros, only the possible ones. So factors of the constant term. This is your constant term, 3. So what numbers multiply to be 3? Well, 3 is 1 times 3, right? So it could also be like positive 1 times positive 3, negative 1 times negative 3. So it's a plus or minus version of the 1 and the 3. This would be divided by the factors of the leading coefficient, and the leading coefficient in this case is 7. So what multiplies to be 7? Well, that's just 1 and 7. So it's plus or minus 1 plus or minus 7. And so rational zeros theorem says when you divide and do the division here for each of these, that will make your list of possible zeros. And they are considered rational numbers, which is why it's a rational zero. But here's the possible zeros for this polynomial. Possible places where it crosses the x-axis. 1 divided by 1 is 1, so plus or minus 1. 3 divided by 1 is 3, so plus or minus 3. 1 divided by 7 is 1/7, so plus or minus 1/7. And 3 divided by 7 is 3/7. So plus or minus 3/7, which means that this polynomial could cross the x-axis at 1, at negative 1, at 3, at negative 3, at 1/7, at negative 1/7, at 3/7, or at negative 3/7. It doesn't cross at all of those places. It could cross at one of those places. It could cross at 2. It could cross at 3, and it won't cross more than 3 because this is a cubic. All right, so we don't know where it crosses, but what we're saying is if it crosses at a nice number, a whole number, or a fraction, it will be on this list. All right, so we're going to find all the zeros of this polynomial. It's not factorable as it stands right now, so what we're going to have to do is we're going to make a list of possible rational zeros, and then we're going to start testing our zeros. So here's the possible zeros. Factors of 20. You don't have to worry about the negative because you're going to put plus or minus in there anyways. So what multiplies to be 20? That would be 1 times 20, 2 times 10, 3, 4 times 5, and that is all of the factors of 20. you have plus or minus for each version, plus or minus for each one. These would be divided by the possible zeros for 6. So 6 could be 1 times 6 or 2 times 3. And once again, it's the plus or minus for each of those numbers. And so the possible zeros, you have to divide each one. And so we're going to make a list. And this is going to be quite a long list, right? But all the possibles. So I'm going to take each one of these in the numerator, divide it by 1. Then take each one and divide it by 2. Then each one divide by 3. So 1 divided by 1 is 1. We'll have 2, 4, 5, 10, and 20. So that's the entire list divided by 1. Now you're going to do the entire list divided by 2. So 1 divided by 2, that's a half. 2 divided by 2 is 1, which is already on our list, so we're okay there. 4 divided by 2 is 2, which is already on the list. 5 divided by 2, so 5 halves. 10 divided by 2 is already on the list. And 20 divided by 2 is already on the list. And we're going to divide each of them by 3. Plus or minus a third. 2/3. 4/3. 5/3. 10/3. And 20/3. None of those were already on the list. 20/3. And then last but not least, dividing them all by 6. So we'll have a 6th. 2/6, which will be a third, which is already on our list. 4/6 is 2/3, which is already on their list. 5/6 doesn't simplify, so that has to go on there. 10/6, that would be 5/3, which is on the list. And 26, which would be 10/3, which is already on the list. So these are possible places where it crosses the x-axis. Possible locations. It may cross at up to 3 of them. Obviously, this list has way more than 3 numbers, right? And so at most, it's going to cross at 3 of them. It might only cross at 2. It might cross at 1. We don't know exactly. So what we're going to do is we have to figure out where in the world this is going to cross at. And so what we're going to do is we're going to start testing these numbers until we find one. So the key here is once you have the list, start testing till you find one number where it will cross. All right, so in your calculator, you can make this happen a lot easier. You're going to use your original polynomial, and you're going to plug in for x, you're going to plug in the number. So for starters, we'll start with 1. So this will be 6 parentheses 1 to the power of 3 minus 41 times 1 to the power of 2. Sorry about that glare. It's literally right above us, isn't it? All right, and then plus 73 times 1, and then you have a minus 20 at the end. When you hit enter, if this is 0, then that is a 0 of the polynomial. So if you hit 0, or if you hit enter, you type it in, you hit enter. If you get a 0, it's a 0. If you don't, then it's not a 0, and you have to move on. So what I'm going to do next is I'm just going to keep going along the list until I find one. The nice thing is you don't have to retype. I'm trying to get that so it glares off there. You don't have to retype it every single time. You can just hit up and it'll go back over, and you can just change all the ones. And instead of doing -1 right now, I'm just going to move on. So I'm going to do 2, 2, 2, and then that was it. Hit enter. When I try 2, I get 10, so it's not a 0. And then you're just going to keep working through your list. So I'm going to do, not 3, that's not on the list. I'm going to do 4. 4, 4, and that's it. And luckily, look at what I got. We got a Sorry about the bells. We got a 0. So what does that mean? That means that 4 is a 0. This polynomial crosses the x-axis at 4. And so that is super valuable information. So we know it crosses at 4. For sure. All right, once you know 1, then you can kind of abandon your list. So we made that huge long list, but we found one really quickly, which was really good. If we hadn't found one, we would just keep going, and we would just keep testing them. And you could test all the positive versions, you could test all the negative versions, all the fractions. Once you find one, though, don't keep going. Just take that number and we'll move on with it, all right? So if we know it crosses the x-axis at 4, that means one of the factors is x minus 4, which means that we can take this polynomial and we can divide it by x minus 4 and continue to find the zeros. So that means that we're going to do some synthetic division here. So you're going to use 4, the actual 0, and you're going to set up your synthetic division using your coefficients up here. So we have 6, negative 41, 73, and negative 20. And then you're going to do this synthetic division process just like from the last section. So the first number comes straight down. We're going to multiply. Then we add and multiply. 68, add, and multiply. And at the end, if it is an actual 0, which we did check, that's why we picked 4, you should get a 0 at the end, which means that there's no remainder. If you get a number at the end, it's not an actual 0 and you typed in something wrong or you did something wrong and you need to go back and check. All right, because this was an x cubed, that means that this is going to be a 6x squared, a minus 17x, and a plus 5. So we know one zero is at negative 4. The other zeros live in this quadratic. So this quadratic will give us the rest of them. And the really nice thing about the quadratic is you have a ton of methods to solve. You could try to factor it. You could quadratic formula. You could complete the square, although you probably don't want to do that. So you have at least 2 methods that you can try. And it's completely up to you if you want to try to factor, if you want to just go straight to the quadratic formula. But you'll get your other 2 solutions that way. This one actually does factor, so I'm going to factor it. So 2 numbers that multiply to be 30 and add up to be negative 17. Remember, when you have a number in the front, you include it in. That's negative 15 and negative 2. So it'd be x minus 15 and x minus 2. But because you multiply by the 6 at the beginning, you have to go back and divide them both by 6. 15 over 6 simplifies. That would be, they both divide by 3. So 5 over 2, right? So that would go to x minus 5 over 2. And then this one, 2 over 6, that's 1/3. So x minus 1/3. And so your other solutions are right here. It's positive 5/2 and positive 1/3. So the question says find all of the zeros. Your solutions are 4, don't forget about 4, 5/2, and 1/3. All 3. By the way, 5/2 and 1/3 were on this list, weren't they? 5/2 was right here, 1/3 was right here. So if we hadn't found that one and we kept testing, we should have gotten 5/2 and 1/3 to both give us zeros in our calculator as well. All right, I know these problems are tedious and there's just a lot going on. And so we're just going to keep working through some and get you some more examples here. All right. So this next one, find all the zeros of the function. This is 500 and 12 are your coefficients here, your constant term and your leading coefficient. So we can make a list of possible rational zeros, and then we can start checking which zeros actually work for the function. In terms of finding the zeros, this is just going to take you some time. Like, the bigger the numbers you're going to see, the more time it takes. And I really wish I had a faster way for you to look through these. If you have really big numbers, like if you're on a test, working on a test, and you come across one that has really big numbers, save it for the end because it just takes time. Because the factors of 500, there's actually quite a bit of them, right? You could do 1 times 500, 2 times 250. 3 doesn't work. 4 works, right? 500 divided by 4, 125. 5 times 100. And this list keeps on going. And then in the denominator, you would have 12, which would be 1 and 12, 2 and 6, right? 3 and 4. And you have the plus or minus version of all of these. So you can imagine how big this list really is. So if it's a homework question and you're working through this and you have this crazy long list and it's going to take you some time, let me know. I can help you find the zeros, or at least 1 or 2 to start with. I can kind of give you some more direction there. So what we're going to do, instead of us testing for this one, I'm just going to go ahead and tell you where 1 exists. There is 1 at 5. So if you were to plug in 5, it would make this equal to 0, which means that we can continue working this question. So we're going to synthetic divide out 5. So our coefficients are 12, 16, negative 225, negative 675, and negative 500. And then when you do the synthetic division, right, your first number just comes straight down, and then you just continue. So 12 times 5 is 60. Add them together, you get 76. 76 times 5 is 380. Add them together, you get 155. Multiply here, 775. Add them together, that's 100. And then 100 times 5 is 500, which is really good because we get a 0 at the end for no remainder there. All right. Because we started with an x to the 4th, that means that this one would be x to the power of 3, x squared, x, and no x's. So here is your polynomial that you have right now. The problem with this is that it's an x cubed, isn't it? So if it's an x cubed, guess what we have to do? We have to do this process one more time in order to find one more 0 so that we can divide it out and go from an x cubed to an x squared. So you can either make a new list based off the 100 and the 12, or you can go back to your original list and just keep going. I will let you know that the next one that we can test is negative 5/2. And if we were in person, we would all, if it was a normal year, we'd all be 10 of us together and we could tag team this and really so that's why the numbers are really big here, because we would all be working together to find these zeros. So negative 5/2. So we're going to take these coefficients from the cubic. Don't go back to the original, just start where you left off. And we're going to do this process with the negative 5/2. Negative 5/2 times 12, the really nice thing is divided by 2, it will turn into a nice number here. So that's negative 30. Add those together, we get 46. Multiply again, we'll get negative 115. Add, we get 40. And multiply, that's a negative 100, which means that we do have a 0 at the end. So that is, in fact, a 0 as well. And like I said, if we were in person, I would have you actually find these, but it wouldn't take us as long because everybody would start in a different spot. All right, and because this was a cubic, this one is now a quadratic. And then last but not least, your options with your quadratic is you can either factor or use the quadratic formula to help you solve this. The first thing that I noticed is that they all have a 2 in them, don't they? Each Each one has a 2. So you can actually simplify this, make it a 6x squared plus 23x plus 20. And then you can either quadratic formula that, or you can try to factor this as well. So I'm going to go ahead and try to factor it. I think it factors. Multiplies to be 120, adds up to be 23. Let's see if we can find them. 5 and 24, that's close. 6 and 20, that's close. 8 and 15. 8 times 15 is 120, and if you add them together, you get 23. So your factors are x plus 8, x plus 15, divide them both by 6. And when you divide them by 6, you can actually just go ahead and tell me what the answers are for both of them. They'll both be negative, and you should simplify them along the way. So 8 divided by 6, that would be 4 over 3. So a negative 4/3 there. 15 divided by 6, that would be negative 5/3 there. And so when it says find all the zeros, you have your 2 here, but then don't forget this one and that one. There are 4 zeros. All right, we'll go ahead and I'm going to skip this next problem right here, and we'll go ahead and just do these last two for some additional practice. So it says, find all the real zeros of the polynomial x to the 4th, blah, 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 right? Given that x plus 3 and x plus 2 are factors. And so because they're factors, that means that they have zeros. So the first 0 here would be at negative 3. The next 0 would be at negative 2. And so we can use these 2 zeros to help us simplify this down. It doesn't matter which one you pick first. So I'm just going to start with the negative 3. The coefficients are going to help me out with the synthetic division. So 1, 3, negative 6, negative 22, negative 12. And we're just going to work the synthetic division and divide out that negative 3. So first number comes straight down, multiply, add, multiply, we get 0, add, multiply, add those together, and multiply again, and add. And the good news is we do have the 0 at the end, so that is like a confirmation that, yes, it does cross at negative 3. All right, because this was an x to the 4th that we started with, that means that these coefficients are x cubed, x squared, x, and no x's. And so we need to take this down one more step to get an x squared. And so we're going to use the other 0, negative 2. We're going to start where we left off with our coefficients, 1, 0, negative 6, negative 4. Don't go backwards and start at the beginning again, because you just end up with a cubic and you're not going to make any progress. So start where you left off and do synthetic division again. Bring down the 1, multiply, add, multiply, add, multiply, add. And once again, we have a 0 at the end, which does also confirm that, yes, that is a 0 of this polynomial. And then because these coefficients here came from the cubic, that makes this an x squared and a x. So our polynomial that we have so far left over is a x squared minus 2x minus 2. And so to find the real zeros, we have 2 of them right now. We need to take this in either factor or quadratic formula. I'm thinking into my head real fast because these are small numbers. That's not actually going to factor, which means I do have to use the quadratic formula. So it'll be negative b plus or minus the square root of b squared. Well, I know that's 4, so I'm just going to save myself some time. Minus 4 times a times c all over 2a. Well, 2 times a is just 2. So I saved a little bit of time putting in and doing some calculations in my head. So we have 2 plus or minus 4 minus 4 times 1 times negative 2 is 12. So this is the square root of 12 all over 2. And the square root of 12 is not a nice square root, but it does simplify into 4 times 3, right? 12 is 4 times 3, and the 4 is a perfect square, so it's going to come out front. And so now I have 2 plus or minus 2 square root of 3 all over 2. And then last but not least, because all of the numbers on the outside, all three, all have something in common, I can divide them all by what they have in common, which is a 2. So this will be 1 plus or minus 1 square root of 3, which is just square root of 3, all over 1, which is just, you don't really have to put everything divided by 1, right? So here's your zeros. You have this here. There's 2 from that. 1 plus the square root of 3, 1 minus the square root of 3. You have 1 at negative 2 and 1 at negative 3. Make sure when you're putting in your solutions, if you get them at the end, make sure you include the ones along the way as well. All right, one more here that we're going to do. Give it a shot. So we have a cubic function. It tells us a root. So this is the number that we're going to use when we do our synthetic division. And so we'll use negative 13 over 5. And then we'll use these coefficients. Negative 416. And then we'll take this from a cubic to a quadratic, and then you can either factor or quadratic formulas. So if you want to hit pause, this would be a great one for you to try on your own. When you're ready, go ahead and hit play, and then we will go over it. All right, so that first number comes straight down. Multiply those together, you get negative 13. Add, you get negative 20. Multiply is 52. Add them together is negative 160. Multiply, we get 416, which means when we add them together, we get 0, which is good news. That is, in fact, a 0 or a root in this case. Same thing. And here is our leftover polynomial. We had x cubed, so now we're at x squared minus 20x minus 160. And so we need to go ahead and solve this. You can either factor, quadratic formula. The first thing I notice is they all have a 5 in it. So I'm actually going to make this a lot simpler and say 4x and 160 divided by 5 is negative 32. So instead of working with this one with the bigger numbers, I can divide them all by 5 because they had a GCF in there and just solve this equation, which I believe factors, doesn't it? They multiply to be 32, add up to be negative 4, negative 8, and 4. So x minus 8, x plus 4. So x would be 8 and negative 4. So you have all the real roots. That would be these two. And don't forget to include that fraction there, the negative 13 over 15. All right, if a question, since we skipped that one, if a question says write it in factored form, all right, so if it says write it in factored form, then what you're going to do is you're going to take your answers at the end and put them back into factors. So all this would stay the same. And if it said, hey, instead of telling me the zeros, tell me the factors, you're just going to throw these back into factors by changing signs. So this would be x minus 8. This one would be x plus 4. And this last one here, the 5 would move up, right? So it would be 5x, and then instead of minus 13, it would be plus 13. So this is the factored form for your original polynomial. It's easiest to just find the zeros and then change them back into their factors. So if anything says, hey, what's the factored form? It's just kind of one last little step there to just throw them back in factors. All right, as you're working, let me know what questions you have, what I can do to help. If you get stuck on finding a zero, So you know, like, so for example, on this one that was crazy long, if you get stuck on finding these numbers, please let me know. I don't have a problem helping you out and giving you some more direction on which way you should go on that and try to help you find one. All right. I know sometimes some of the questions we get, the numbers are really big. And so I will help with that for sure. All right. Yeah, that's it. Good luck on the homework.